That's what we're assuming. We're proving the other half.
But you have an idea of
No, true. Yes. Right. We prove, if we prove that B is an ideal of G, then we'll be done because G is simple. So he claims, so the claim 1, B is ideal. And this will do it. So, and this will imply 2, because then B has to be 0, and then has to be 0 because sits inside G0, so cannot be dual algebra. So this, and this is the claim I could not verify, the first one. But I give you as a simple exercise. So this is how he does the first. Then he defines C, which is the bracket of G0, G1. And he claims that G0 plus C is an ideal. So if G0 plus C is an ideal, I think you can prove, because it means that, okay, if this is an ideal, then G simple will imply that this is G0 plus C is equal to G, and then this will imply that this is G1, which is the property 3. Okay, so this will give 3. This
Doesn't that claim just fall from using the Jacobi identity bracket?
in fact, that's what I tried. I could not do. No, one I could do. Maybe this one I could do. Yes. This is the only one I can do. This is Jacobi. Yes, this is the one I can do. This claim is the claim I can do. This use Jacobi, it's not Hammer. And then there is the third one. No, but I'm not upset with this B, because I couldn't do. And then there is the other one. What is it? Right. Wait a moment. Right. Yes. And then this one, he does it directly. He's not making a claim. He's making a little claim for the first one.
2 is the third
3.
point.
Yes.
1 is the second.
Yes. I'm sorry, I'm disordered. Yes. So but I say 2 and 3, right? Maybe I should call it A and D to avoid this.
Why not? 2 and 3.
No, it's logically not the same. Now the other one is, so the last one serves to prove number 1.
You use the letter A for the ideal B and the letter B for the ideal C.
No, but the B is...
And now C for the ideal A, that's fantastic.
Allora mi ripete, no, perché guarda che tu fa lezione qua dentro, cioè veramente, io una volta vengo alla tua lezione di algebra superiore, una volta vengo, giuro.
Oggi, lo smetto. Oggi.
Ma oggi c'ho conflitto, vengo mercoledì. No, vengo mi diverto, perché ho diritto anch'io però. No, così siamo tutti contenti. Allora, so this, so the claim that does the first one is the following. And if you know that this is, so this is the claim. So if you know it is an ideal, I think you can, it's straightforward that it has to be, this property has to be true. Because, so if you take A inside the G1, so I write it's obvious, but let me think a little bit of, right. You have to make some calculation. But so I'm telling you that if you can prove that this is an ideal, this will give you this, because I'm making some calculation, but I don't want to make them because it's not. The problem is that I cannot prove it is an ideal. This is the one So this one and this one I just could not prove.
For the first, I think it's enough to prove that B is an ideal in G0.
Yes, yes, yes.
And then it follows from Giacobinetti.
I tried, could not, but I made a small attempt. When the calculation did not come out, I got accepted. Very simply, very upset. So this is my little attempt. I couldn't do it, but it's an exercise. No, to be honest, I didn't want to spend time because I figured that we don't need this. We have so many things to do. I figure, okay, let's leave to the audience some. No, ma non è che ci ho perso tanto tempo, non mi è venuto e ho lasciato lì. No, I don't think it's difficult, but it would be nice because Franco is right. Sometimes these people make a claim and then the claim is false, so it's better. So let's devote the time to the important things, which is the verification that the SL is simple. So we take finally the first example. So we take M different from N. Because if M is equal to N, let's spend just a second about this. So I remind you what this is. So this is A, B, C, D, the trace of A equal trace of B, which I can say super trace of A, B, C, D equals 0, because we remember that the trace of a matrix is the trace of first block minus the trace of second block. Okay, let's take M different from M, because the case M equal N I want to discuss in detail later when we look at the root system, and then it will be better. Let's just to have the example, look at this only. I need all of your help. No, I'm joking. I think I can do, but... So let us look at what is, in this case, G0, G1, and what how we can discuss these three properties, right? This is, and we need to understand the structure of G1 as G0 module, right? This is very important because this will tell us the possibilities of our A. Okay. Okay, so G0 is, it is very clear what it is because it's made of all these matrices I didn't think how to say this. It is one of these obvious things that one should think before lecturing. Okay. You see, this is not SLN, right? Because SLM and SLN have a trace 0. Right. So certainly this G0 contains all the matrices of trace 0 here and trace 0 here, but the point is that I have to allow those matrices that have a trace non-zero. So yes, I put K here, times the identity. And this fact I should prove, right? Because to me it is obvious, but if it is obvious, I should be able...
No.
Yes, it is like this.
If M is different from N.
The identity.
The identity.
The identity, so it is plus K. So let's not write the K, let's write just the K. So it's write K over the field. The K is characteristic 0. We can take K equals C just to, but this argument is, the problem is that when I talk about representations, I don't want to worry about the complete reducibility. And characteristic non-zero, we have a problem. That's why I need characteristic zero algebraically close.
Yes, but it was not the identity that case. The identity is not in G0.
No, it is, yes.
But it's,
it is not the identity.
this is given by any diagonal matrix
dimensional.
whose trace is 0 and with the restrictions not 0 in the first
So I think what we can do, right, we could establish isomorphism by taking, so if you have AD, why didn't I do this before? So I can subtract to A the trace, the identity times the trace, and to B the identity times the trace, and then I put identity, right?
No,
No?
not for the identity.
What do I do?
You can take a matrix n times, n times.
No, so here I put A minus, so I want this to have trace 0. So I need to put, what do I need to put here? So something like this, right? And then I put trace A here.
Yes.
And then, no, but this is one of the stupid things I should have thought. I didn't think, of course. D minus, and then I do 0, 0 trace A. E here I put trace A. Dai. Ci abbiamo due algebristi qua. Datemi una mano, così.
No, you
First.
No, va bene?
This is, you don't put trace A, but you put a matrix having trace A, 0, 0, trace A, 0, 0.
Perché la mia non va bene?
No, ok.
La
Sì,
mia va bene.
trace A. In the sense that trace A is a matrix.
No, trace A is a number. Trace A is a number. The trace of a matrix is a number, right? It's the sum of elements on the diagonal.
Yes, but how can you, I mean, you cannot put a number, you have to see that number as a matrix.
Yes, in fact, I put the diagonal matrix with this is last entry.
No, trace A.
No, this is an element of K.
Yes, but K does not sit inside there, so you have to
No,
see.
I'm making an isomorphism. So this is G0.
Ah, okay.
And this is
Okay.
SLN K.
Okay.
Okay? So I should have thought about this. This is kind of obvious things that, okay, they're obvious, but, so, Franco not happy.
No,
This
don't
is,
worry.
no, but Franco,
Don't
this
worry.
is very clumsy and inelegant. There is certainly a better way to realize this isomorphism, which does not depend on choice of coordinates.
Don't worry. Don't worry.
This splitting is, there's more than one such splitting like this.
Of course.
So, I mean, you just have to pick one. It's not, there's no claims to this thing. If not,
No, I'm not making a canonical claim, just the same. For us, it does not matter how this case sits inside. It may matter in the future, but now it doesn't.
Yeah, but he was saying that you cannot do better.
I cannot do better. Thank you, Stephen. I can do better.
Yeah, I mean, there's many, you could have put the trace A in some of the other diagonals and you get another splitting.
Now let us look at the G1, which is the important thing. This is the one I devote some thinking, not this. And K, notice, it's important to notice, that this K, no matter how you realize it, but this plays no role in the bracket, because this K will act as a central element, right? So when you do bracket, it sits on the diagonal, so we give. So for the bracket, it matters only this SLM and SLM. Okay, so it's important fact. Now let us look what happens for the for G1. Okay, so I know already the answer, but I want to derive. So G1 is this 0, B, C. And let us look, I want to have this little, I will have the time to do this little calculation. I think it is very instructive if we do the trivial calculation. So let's do bracket I could do say by exercise, but I want to do this. So, so let's write B C0. Okay, so I do the bracket, so I get so here is 0, 0 AB, and then 0, 0, 0 minus, and then here I have I have to multiply the other way around. So I get 0, 0, and then I get CA, right? No, I should get no. Here I get sorry.
Yes, let's see.
No, this I'm making a mistake. Give me a hand because oof.
DC.
DC
Okay.
here, right? I forgot the DC here. Right. When I do the other way around, I get so BD0, BD, thank you. So I get BD here, and then I get CA, right?
Yes.
Wonderful. Okay, so let us look at, so first of all, we realize that, no, let's write. So I get 0, AD minus BD, and then BC minus CA, 0. So we notice that B has an action on G0 that is, see, it is stable under this action. So there will be a submodule, this block, right? And this one also will be a submodule. So we know that there is so it is 0, okay, no, 6. So here will be 0B, 0, 0, 0C, 0, 0. And I call this G1 plus and G1 minus. So certainly G1 is not irreducible. So it will split into these two. Now, how can you prove irreducibility of these blocks? So I claim, but I'm lucky because there are all these people that are so knowledgeable sitting here in this row. So G1 plus, what is this action of G0 on G1? We notice that there is action of SLM from the left, and then there is action of SLM on the right. Okay? So we recognize that there is this is the usual representation, right, of SLN acting on acting on the right, on the left. This is the contra-gradient one because it acts on the transpose. So I claim that this is this G1 is Km tensor Kn star, meaning the contra-gradient, the transpose action. Let us look more in detail. Okay, I will. So there is this minus sign that disturbs because I want to put a plus, but I will explain. So here we have this situation, okay? So I'm looking at the action of the pair AD. This is an SLN M and SLN on and I say that so this is a Lie algebra, right? G0. I write a G0 semi-simple to mean this is not G0, but this is the semi-simple part of G0. Because remember, I just erased it, but G0 is SLM plus SLN plus K. So when I write a semi-simple, I remove this part. So when I have a Lie algebra acting on a tensor product, it means that
No, sorry, Rita.
no,
I am
yes.
just having problems with, is it Km and K? Oh yes, because it is a yes, no, Km.
So I'm defining this. You see, I think it's an I don't
No,
know.
it's- Sorry, just 1 moment. As a K vector space,
Yes.
G1 plus, which dimension does it have?
So as a vector
Not
space is the tensor product of Km times Kn.
Yeah.
So I'm using M by N matrix. Right?
It's an M by N matrix, so it
okay,
is.
okay.
Okay, I'm saying, I don't know how to denote this. So there is a tensor product, correspondence between tensor product to vector spaces and matrices, right?
Mhm.
The thing is that the action is not the usual one in some sense that, so I define this by definition, the action is, so I do AI, what do I do? God. Why don't you guys help me? So this is, should be AI times a J, right? So I don't touch a J. And then I should do minus AI tensor EJ star B. Is this the action? Which should be the same as B star, which is the transpose EJ. So it should be the same as this, right? Ne fate voi altri?
Ma cosa vuoi proporre?
Sì. So I'm making a claim. I'm saying that G1 as a vector space, it is a tensor product, and this is fine. Because tensor product equal matrices, right? Once you fix the basis. That is, but what I'm trying to claim, I'm making a claim that is not just a claim on the vector space, I'm making a claim of representations. So I'm saying that as a vector space is the tensor product. As a representations, I have G0 semi-simple act on this tensor with this action. So I'm making two claims, right? So this is a stupid claim because it's a claim on vector spaces, but then it becomes less stupid when I'm making a claim on the representations. So it is.
We're saying that it is the natural representation of.
It's a natural on the first. Yes, and it is the contra gradient on SLN. No, ma anche io non ce l'ho chiarissimo questo punto sulle rappresentazioni. Because I would put a plus there, so the fact that there is a minus is disturbing. No?
No, but in the dual representation
You put a minus, is the dual representation. There is a minus, okay.
As for groups, you go
No,
from
yeah.
one side to the other side.
Ah.
The inverse.
Right.
the
On the algebra you need a
You go
minus.
the other
Okay,
side.
now I feel better. Is my ignorance in representation is
Groups,
is
inverse of
shameful.
the transpose and the
Inverse transpose is
opposite of the transpose.
oh, right. Okay. Right. No, I should know this very well. It's a shameful because yes. Now, one should prove that this is irreducible. But in
Because
some
the base is irreducible, I think it's easier than doing that.
because you just take an element and you show that you move it where you want.
Yes.
This is the fact.
You just need the bigger of the two matrices, A and B, I think. I mean, if
It's
n
clear
is-
how you do it. Yes, because to prove it is irreducible, you need to show that there is no proper submodule. So you take E1 times E1, and you show that E1 times E1, you can take it to any element of the basis. And this you can take it because there is transitive action of SLN on first and on second also. So this is standard.
No, but
Non è contento.
no, I'm not happy because this year meaning there is no proper subvolume containing an
No,
element
I'm
of
not
the
saying it's
basis.
simple. I'm saying this is irreducible. This G1 plus. Now,
But by proving that there is no proper submodulum which does not contain any element of the base.
Yeah, you're right.
no, but it doesn't matter.
You
Yes,
can always.
you can. No, okay. You do with E1 tensor E1, but the truth is that the action it is there is
Yeah,
no work to
tensor
do.
Vj.
It's transitive. You can send it wherever, but you're right.
Yeah, continue.
What you can take, I think. No, let's not do this.
No,
It's,
okay, no, I believe you.
No, but you're right. It's not enough to prove basis element. No, but if you prove basis element, you can do a lot. Okay, now let's verify it is simple because see this A is G0 submodule G1, but G1 decomposes. So G1 decomposes in G1 plus G1 minus, which is the other one. They are irreducible and they are inequivalent. This is important because when you look at this one, it will be Kn star Kn, so they'll be inequivalent. So the only submodules that you can have inside the G1 can be only this or this. If they were equivalent, then you can have some diagonal thing embedded inside, strangely, right? But
it's not clear that they are not equivalent.
no, it is clear because the G1. No, but no.
Yeah, but
No,
you can
I
prove this is Kn times Kn star, but why they are not equivalent?
No, because this is G1 minus, right?
Yeah.
You know that okay. You have to prove you have Km and
Yeah, it's always an acronym.
yes. You have to prove this is V and W, right? So this is V prime and W prime. Now, you know that this we know, don't we? This is the problem. No, I'm asking, is this your problem?
For example,
Yes, no, but this is a known fact that if you take the dual is not equivalent to the representation. I can try to prove, but I thought that you were telling me.
But this is not true in any category. I mean, for vector spaces, this is not true. So it's you need an argument to show this.
Okay, I will come with the
For
argument.
module.
For module,
Same
is-
for module, it is not good for module.
Okay, so let me come with this.
Vector
But
spaces, yes. Yeah, obviously, as module, they are not natural.
they're not naturally isomorphic. But, okay, let me come with this argument. Okay.
And then, even if you know this, then when you do the tensor product, you may end up with an equivalent representation.
Okay, okay, I realize that this factor needs a more careful motivation. But let us assume that this G1 plus and G1 minus are not equivalent. Then if you take their direct sum, then the only submodules will be G1 plus and G1 minus, no other things, right? Because of this. And then you can verify these properties directly. So if you, 1, 2, 3 of lemma, you can, because see, the point is that the G1 is a faithful G0 module is coming from this calculation. Because this is faithful. If you it's an exercise, but if you put this equal to 0 for all possible B and all possible C, you realize that A and D have to be 0, right? So the property 2 is clear from this little calculation that I made. Property 3 is also clear from this. If you take G0, G1, you find again G1. I mean, I'm not saying it is. I'm not saying it is straightforward. I'm just saying it comes out from this calculation with some manipulation. The only problem is the property 1, but you take A equal to G1 plus or G1 minus. So you have two checks to make, one for G plus and one for G minus. And there are two. I checked it. It's, I mean, it's just a, what can I say? It's, I don't want to say it's a stupid calculation, but it's a calculation.
Can I go to the blackboard? Because
No,
I have a doubt in that
devo
one.
finire.
No,
Tizio.
just one moment. Because,
Cosa c'è?
so here,
Ok.
if A satisfies this, then
Uh-huh.
G1, A is G0.
Yes.
So this is G0. Okay, G1A.
G1A I calculated. Just a second. Yeah. It has some expression. But what
Okay, I'm assuming
Yes.
it's true. No, this is G0. So here is the G1 bracket G0 is contained in A. But then G0,
No,
G1 is G1.
I think our only hope is to start the next time doing this little calculation. Let's do it.
You're not listening to me.
Because I don't
Because
agree
here
with
you are writing that G1, G0 is contained in A, and here G1, G0 is G1.
No, but I'm very calm because I know I made the calculation, so we can verify this property. But we cannot do it now because I have to go in a different place. So it will have to wait 1 week.
Just
No, it is.
two things are not.
No, I understand there is a problem, but very luckily this time we can settle it with the calculation. Va bene? Next time I will. No, I will.
So maybe she's just saying no G0 submodulo G1 can have that property.
Yes.
She's saying that G1 plus can be used as an A.
Yes.
One.
No, but you have to use it as A because it's a G0 submodule of G1.
One in reality.
No, the A is either G1 plus or G1 minus because this property.
Yes, but it does
No.
not satisfy
It will not.
one.
It will not satisfy one.
It will not. Yes, yes.
Oh,
I
okay.
say void condition. We have to. So, but you have to check it because this says for all G submodule do this.
But it's trivial, you don't have to check because otherwise the tree cannot be true.
Ah, I see. Okay, let's do the
It's always
calculation
void.
next time. There's.
It's always void.
I write it void.
That's
Yes.
why it was strange to me.
Ah, is a always void condition. That's strange though.
No, it is. You cannot.
No, ma adesso
if
non posso.
A is a G
Spiego, non posso.
G0 submodulo G1, it cannot have